So we've now seen the conditions that a function must maintain in order for an inverse to exist. We've seen the definition of the inverse of a function, but how do we find such an inverse? So the following is procedure to help us find the inverse of a one-to-one function f. And we can do this in 4 easy steps. So given a one-to-one function f, the equation for the inverse of that function can be found in these 4 steps. So the first thing we do is replace f of x with y. We then want to interchange or switch the x and y coordinates. After that, we have a new equation in which we want to use that equation and solve it for y. And then last but not least, we can replace y with f inverse. Now, as always, don't forget to check your work. So to make sure that we didn't accidentally make any algebra errors in our finding of the inverse, we want to make sure that we substitute the inverse or the equation of the inverse we found into these 2 compositions to make sure that the definition of the inverse holds true. Additionally, we want to keep the following important features of an inverse function and their graph in mind. So in addition to using the formal definition or the composition identity to check that a function and its inverse are in fact inverses, we also want to keep in mind that the domain of our given function must be equal to the range of the inverse function we found, and that the range of the given function must also be equal to the domain of the inverse function we found. And last but not least, we also want to keep in mind or check that the graphs of the given one-to-one function and the graph of the inverse function that we found must both be perfect mirror images across the diagonal line y equals x.